And welcome to today's video where we're going to be doing 36 valid Sudoku. So our goal is to determine if a 9 times 9 Sudoku board is valid, and only the filled cells need to be validated according to the rules. Each row must not contain digits 1 to 9 without repetition. Same thing with the columns and also for the sub boxes. Okay, so this makes sense. We'll give an example here. It's in the format like so, where we have a 2D array where the empty spaces are represented by dots. That makes sense. And then we have an example of 1 over here. Okay. So first things first, and what I'm thinking of doing is basically having three different sets. Which represents the rows, the columns, and the boxes. Yeah, boxes. Or actually, three different hash maps which have sets which represents the rows, columns, and boxes. So with these sets that contain hash maps, we can add the numbers into each set and check to see whether or not they're equal to each other afterwards. So what I mean by that is, let's say like you have like number 5 over here in this first example. We can check to see, we can have a set for this specific row, we can have a set for this column, and then we can have a set for this box. And we can check to see whether or not the number 5 is contained in any of those. So if it is, if it already is, if that means we've already added it before in the past, and we're going to return false, it's not valid. Otherwise, we want to return true. We want to keep going. So yeah, and then we're going to be adding those numbers to the hash maps as we go along. And if we manage to make it to the very end, then we'll know that it's a valid Sudoku. So I'll go ahead and begin making this. First of all, let's import the default dict from collections, which is basically a hash map that has a default initialization. Next thing we want to do is create our hash maps. So we have default dict, where we have a set, call, and then we have box. And then from here, what we want to do is loop through every single value in the board. Board for j length. Board 0 because we want to grab the column. What we want to do now is basically check to see if it's a dot, first of all, you want to keep going. So if board at ij is equal to a dot, you want to continue. Otherwise, you want to check to see if board ij, if this value is in the row at the given index, or board I j is in row at the given column, or board I j is in the given box. So box, we have to take into account both the index and the column, and we'll notice that there's 9 different combinations. So let's say at the very end we have this one over here, right? And there's 9 elements total, and there's 3 boxes. So we would have to divide it by 3 in order to determine which box it belongs in. So what we can do is, or if the board I and j is in the row where we have a tuple, or where we have a set, a tuple which contains the I divided by 3 and the j divided by 3. If it's in here, yeah, a tuple where I divided by 3 and j divided by 3, if it's in here, then what we want to do, what we want to do at the very end is we'll know for sure that it's in it and we want to return false. Otherwise, we want to add it to the row, the column, and the box. So we want to do row.add board ij. Same thing for the call. And then for the box, we want to add a new tuple with I divided by 3 and then j divided by 3. And then at the very end, if we manage to make it through all of this, we can go ahead and return true. Yeah, so just to check for any typos, we initialize these boxes here. We go ahead and take a look. This, and this. For I in range length board for board 0. Check to see whether or not they're equal to the dot. Then we continue. Otherwise, check if it's an I, j, or the tuple in row. Oh, this should actually be box. If it's in the box. And we don't actually call, I don't know why I put the open parentheses here. If it's in the box at this range over here, then we can go ahead and return false. Otherwise, we want to keep on adding it to the thing and then return true at the very end. Let's run this and see. Oh. Whoops. Sorry, I was working a lot in React. Or like ES6 JavaScript previously, so. Okay. Tuple expected at most 1 argument and got 2. Oh. Actually, instead of, I think it's the correct syntax is just initializing it like this. Because if you pass in a tuple, I think you'd have to pass in a list object, if I'm not mistaken. Oh, right. We want to add the row I, we want to add the row j, and then we want to add the box here. Board I and j. It's my mistake. Okay. Let's check to see if we have any other issues here. Yep, call j. Should really double check this. Okay, fully accepted. Let's go ahead and run this. Nice. O of we've fully accepted. The time complexity is O of m of n times n, where n is the rows and m is the columns. And the space complexity is going to be O of m times n as well, because at worst case you could be storing. Actually, it should be it'll be an O of 1 space complexity, because it's storing like a static set of like numbers from 1 to 9. Or actually, if we increase the number of numbers in the Sudoku thing, then we would also have to increase the set as well. So it would actually be, yeah. I'm actually kind of curious to see. Pretty sure we can analyze the space complexity here. Okay, I'll comment down below what the space complexity of this one should be. Let's actually take a look at the solutions. Space. Okay, yeah, so same thing. Yeah, that's what I was thinking. Because you're actually iterating through 81 digits, but so it's gonna be constant space because it doesn't increase with the size of the Sudoku board. Well, like it doesn't increase with the size of elements, right? But if you increase the size of the Sudoku board, then it grows as well. So I'm gonna say this is O of 1, like this says O of 1 time and space, just because it's a digit and Sudoku boards are static value. But yeah, I guess it depends on how you interpret it. If you interpret it as the Sudoku board growing in size, we'd also have to increase the range that this would be at. So yeah. Okay, thanks for watching.